The next and last set of things we're going to talk about is when we quantify risk. So let's say we have a number and we want to test it out. There are three methods. We're going to do two now. We'll do another one next week. And the two we'll do now are sensitivity analysis and scenario. The sensitivity is, well, let's work it out. What's the base case? Well, we have 1,000 units at $25, so the value of our sales is $25,000. The cost is 4%, so the 4% cost is 4% of what? Of that, and our profit is therefore revenue minus cost. All right, so that's our base case. And we say, well, let's see how sensitive things are. What if our unit sales is off and it goes more by 25%? So that is equal to the sales times, open parens, 1 plus 20%. So our sales are 1,200, right? You probably knew that just by looking at the number. And then let's just play it out. Oh, okay, the sales price is the same, and the revenues are the same calculation, but now because we sell more, we make more, the cost is still 4%, and our result there is we sold more, so we pay more, and our profit is higher because we have a very profitable business here. That's if good things happen. If our unit sales are off in a good way by 20%. What if we're off in a bad way? It goes less by 20%. So now we take the unit sales would be 1,000 times 0.8 because we lost 20%. The sales price is the same. Our revenues will have the same relationship. And then we're still at 4% cost. And 4% of revenues is that. And therefore our profit is lower because we sold less items. So it drops to 19,000. What if we had costs go up by 10%? So now these stay the same. And this changes. So this is 4% times 1.1. And the cost then would be 4.4% times revenue. And our profit would then be 23.9, almost nothing. Now, what if it goes down by 10%, right? So these stay the same. We have this number times 0.9 because it goes down. So the cost will go down and our profit up, right? So what we've done is to do some sensitivities around two variables. The first variable are sales, plus or minus 20. And the second one are costs, plus or minus 10. And we see how sensitive our profit is to these changes in assumptions. What do we see is that we're pretty sensitive to this variable of unit costs. Look at how much it jumps and drops. But we're not as sensitive to the cost changing. It makes some change, but not much, right? And the reason, just logically, that you could have done this without doing all the math. And the reason is that the cost is so low anyway. It's only at 4%. So if it grows, it can go quite a bit higher without really hurting us. Whereas the unit sales, that's where everything starts. You start tinkering with that number, all kinds of movement occurs, right? So the results are not particularly shocking to any of us, but it's in line to illustrate what we're doing in sensitivity analysis. All right, next on the right side, we'll do scenarios. Now scenarios aren't like doing one variable at a time, tweaking it, which is what we did in sensitivity. Now we're saying a scenario, like scenario I wrote here, everything goes viral. So if it goes viral, the unit sales are going to go nuts. It's going to go to 2,500. And our price will still be the same because we didn't change price. So our revenues will jump because of our massive viral effect in our business. And our cost still 4%, which means our total cost will be 2,500 and our profit. And they say, well, what if you get bad reviews? Uh-oh, we won't sell 1,000. We're going to go down to 700. And then the 25 will still hold, and the sales amount will then drop pretty dramatically. Our cost is the same, so the cost will be that. And whoa, we go from 24,000 down to 16. That's not a good thing. Competition enters, and what happens is we're going to take a little bit of a hit on our unit sales, but not only that, they're pressing on our costs, and they're driving up our costs because they're grabbing our low-cost product So now instead of 0.04 is 0.05. What happens then? Well, revenue will go to 22,500. So we're down from where we hoped. But also, we took a double hit because our expenses went up as well. So now we drop all the way to 21,375. So the difference between sensitivity analysis, where you take one variable and tweak it a little bit at a time to test just that factor, a scenario could have multiple things changing, illustrated most by the last item here, which is in the scenario of competition entering, we both take a hit in our unit sales and our cost structure goes up because they're starting to compete with us to buy raw material. So this is the difference between a scenario and a sensitivity. Summarizing this chapter then, we saw some basic statistical concepts, mostly review, I'm sure, for you. Mean, median, standard deviations, Pareto, quartile, decile. If I rattle those words off and you say, ding, 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 I've got it, we've done well. Second is, we looked at a whole suite of different performance tools that are used by corporations to better their operations for quality and for cost performance. Root cause analysis, the Ishikawa, lean manufacturing techniques like Japanese manufacturing techniques, continuous improvement like Kaizen, total quality management, Six Sigma, which is a certification for that, and finally the wide set of tools in benchmarking, us against some other static measure to see how we're doing and find improvement opportunities. In overhead, we saw the use of ABC, activity-based costing, and how that would add to the precision of allocations. Then we saw financial relationships that show profitability, productivity, profitability per unit of capital, and these could be used for your own company as a whole, or a company against other companies in the industry, or across different industries, or within a company for its products. So these ideas of gross margin or operating income or asset utilization, these are concepts that go across all of these, from companies to products to competitors. Then we looked at some refinements using the probabilities of things happening. We looked at expected value, which is a pretty straightforward application of using probabilities. Then we took one slightly more advanced, which is to build out decision trees with different nodes for things that happen along the way. And then branching, that's why it's called a tree. And that can lead to some more precise probabilities and outcome measurements to lead to more precision on the number. And finally, we looked at, well, what if we have a base case and we just want to test it out a little bit? What can we do? We looked at two methods. One is sensitivity, where we take one variable at a time and tweak it up or down. Or we do scenarios, where we tell a story. The one that we did was a competition enters, which makes it harder to sell the units you intended. And furthermore, they drive up the cost of raw materials because they're competing with you to buy raw materials. Therefore, your costs go up. Right? That's a scenario where you can and are expected to change more than one variable, because the scenario is more complex than simply tweaking one variable at a time. All right, so thanks. I will see you in class.